Okay, in this video we're going to use to draw a graph of quadratic in order to solve a practical problem. So it says the farmer has only 60 meters of fencing for his sheep. He decides that only one side of his enclosure will be a building and the other three sides he will use his fencing to make a rectangular enclosure. A. Find the possible dimensions of the enclosure to have an area of 288 meters squared. B. Find the dimensions of the maximum possible area that he can enclose and the value of this area. So, what first step would be to draw a diagram. So, we've got a building here, and we've got some fencing going around here. Okay, so this all counts as his 60 meters, and it has to be a rectangle. The thing to bear in mind is that this length here and this length here are the same, so we'll call those x. We need to introduce a variable, so we'll let x be the width. So we'll label that x. That means also that one is also x. And then what would this length here be in order for all of this to add up to 60? Pause the video here and see if you can work this out for yourself. The total length of the available fence is 60 meters, and therefore this would have to be 60 minus this length, so it's 60 minus 2x. So once we've got a diagram with the dimensions on it, now what we've got to do is form an expression for the area. So the required area will be 288 meters squared, which is this here, in order to answer part A. So, going back to our diagram, how would we find the area of this green bit here? If we had the length, we would do this length multiplied by this length. Therefore, we can say the area is the width times the width times the length. So that's going to be x, this length here, times the length, which is 60 minus 2x. Let's expand the bracket. So we're going to get 60x minus 2x squared. So we now going to draw a graph of A is equal to 60x minus 2x squared. So in order to draw the graph, we need to make a table. So we're making a table. So we're going to put the x values here. We're going to go up in 5. 0, 5, 10, 15, 20, 25, 30. I'll stop at 30 because if I put 30 in here, this is going to be 0. And then we need to work down the side here, 60x minus 2x squared. Remember, these two column rows here are just for working out the answer. So then I'm going to do 60 times 0, which gives me 0, 60 times 5, which gives me 300, 10 times 60, which is 600, 50 times 60, which gives me 900, 20 times 60, which gives me 1200, 25 times 60, which gives me 1500, and 30 times 60, which gives me 1800. Then I'm going to do minus 2x squared. So I'm going to do minus 2 times 0 squared, which is 0. Minus 2 times 5 squared. That means we square the 5 first, and then multiply by minus 2. So it's minus 50. Minus 2 times 10 squared, which gives me minus 200, minus 2 times 15 squared, which gives me minus 450, minus 2 times 20 squared, which gives me minus 800, minus 2 times 25 squared, which gives me 1250, and minus 2 times 30 squared, which gives me minus 1800. Now what we do is we add these two columns together. I'm just going to correct myself there, 2 rows together. So 0 plus 0 gives me 0, 300 minus 50 gives me 250, 600 minus 200 gives me 400, 900 minus 450 gives me 450, 1200 minus 800 gives me 400, and 1500 minus 1250 gives me 250. 1800 minus 1800 gives me 0. as we got only one maximum point, we don't really need to take any extra column on this for this particular graph. So we will plot 0 and 0, 5 and 250, 10 and 400, 15 and 450, 20 and 400, 25 and 250, and 30, 0. So, drawing a set of axes, so here I'm going to make each big square 50, going up to 500, I'm going to call this one A. Along here, we're going to go 5, 10, 15, 25, 20, 25, 30 will be the X. And we're going to plot these points. Now, plotting the points carefully on the diagram, so we're going to plot here 0, 0, 5, 250, 10, 400, 15, 450, 20, 400, 25, 250, and 30 will be 0. So notice we get a nice smooth sort of quadratic. So with a pencil and drawing the graph as smooth as possible, we get a graph here and we label it A is equal to 60x minus 2x squared. Now we were told that the area was 288 meters squared. Well, that one there is going to be, that there is going to be 280, that would be 290, so we're just going to draw a line across the graph, just lower than this line here. And you use a ruler for this, and you use a dotted line, and you must show on your graph how you've got your answer. So drawing in a dotted line across with a ruler, just slightly lower, and then we're going to take the nearest value here, which is going to be read down. Again, showing on your graph, we've got 6. So when x is 6, that's the width, the length is going to be 60 minus 2 times 6. Remember, the length was 60 minus 2x. So that's going to give a length of 48 meters. So one dimension is going to be 6 meters by 48 meters. For the other one, we're going to get another one possibility here. That gives me a value of 24. Remember, 2 squares along here is 24. And that's going to give me x is 24. And then the other dimension, the length, 60 minus 2 times 24 gives me 12. That gives me dimensions of 24 meters by 12 meters. These has to be the width. These has to be the length. Make our answer a bit clearer, we'll write W for a width and L for length. It has to be like this way around. This has to be the width, this has to be the length. Now we're asked for the maximum area. As this is a function of area against x, the maximum area occurs at this particular point here. So again, we have to show on our graph. So drawing a line across, this is the maximum area. And then reading down, we only get one value of x. The maximum area will be 450 meters squared. That's the maximum area. Now x will be equal to 15, and the other one will also be 15, because if you did 60 minus 2 times 15, it's also 15. Sorry, I'm going to correct myself there. If you did 60 minus 2 times 15, it would be 30, so the length would have to be 30. So again, we better write underneath here that this is the width by the length. Okay, so for the maximum area, the width of the fence would have to be 15, the length would have to be 30. Okay, this has been a video to show you how to draw a quadratic function in order to work out the dimensions needed for a rectangular enclosure for keeping sheep. I hope you've understood, and I thank you very much for watching.